Welcome to class, my name is Tom, the course instructor of this video. In this video we are going to look into Python objects and learn how Python handles objects and variables. Okay, let's get started. Everything in Python is an object. There are many different types of object. For example, the integer 100 is an object. The integer 101 is another integer object. Similarly, the floating point number 100.0, the string hello, the Boolean value true, this tuple, this list, this dictionary are all individual objects. Every object is unique and has its own unique identifier, or ID for short. Let me show you how to get the ID of an object. We will be using the ID function to get the ID of an object. Passing the object to the ID function, the ID function will return the ID of that object. Then we will print out the ID using the print function. Okay, open the PyCharm editor we have installed earlier. We are going to process our Python codes with it. We have installed PyCharm on both Windows and Linux. Both Windows version and Linux version will do. First, let's print out the ID of the integer object 100. I added a description in front of the returned ID so that the printed outcome is easier to read. Also print out the ID of the floating point number 100.0. Then the ID of the hello string object. The ID of the Boolean true value. The ID of a tuple object. And finally the ID of a list object. Run the program. Got the IDs of all these objects printed out. As you can see, different objects have different IDs. Some questions. What exactly is an object ID? How does Python create the ID? Is there any rule that Python follows to formulate the ID? Python uses the address of memory location where the object is stored as the ID of that object. Let's run the program module again. Upon execution of the module, these objects were created in the memory. Python used the address of the memory location where the object is stored as the ID of that particular object. So every data object has its own unique ID. For example, this is the ID of the 100 integer object. And this is the ID of the 100.0 floating point number object. Now we've created 6 objects of 6 different data types. How can we access these data objects in the program? Obviously, accessing them using their IDs is not a good idea. Here variables come into play. In the program we access data objects using variables. First, how to create a variable? We create a variable by assigning a value, or more accurately, an object to it. Here, from A to F are all variables. They are names created upon the program assigns an object to them for the first time. So a variable is a name that the Python program uses to refer to a particular object and to access that object. Okay, let's show this with a simple program. First type in A equal to 100. Then, print out the value of A, the ID of A, and the data type of A. The type function is a Python built-in function that returns the data type of an object. Then repeat the same for other objects. Variable B equal to 100.0, variable C equal to the string hello, variable D equal to true, variable E equal to this tuple, and variable F equal to this list. Okay, run the program. These 6 data objects were created in the memory. Let's have an explanation how they were related to the variables. This assignment statement assigned the integer value, 100, to variable A. What this statement actually did was it created the integer object 100. And at the same time it also created a variable called a, pointing to the integer object it just created. In this way the program can access the integer object 100, which is located in the memory address 14248797072, by referring to variable a. That's exactly how this statement accessed the integer object 100. The print function, the id function, as well as the type function, all accessed that object by referring to variable a. Other assignment statements such as b equal to 100.0, c equal to hello, did the same things. They created the objects in the memory, and along with this they also created the variables and made the variables pointing to the objects. This is what an assignment statement does. So variables, indeed, are names pointed to or mapped to the objects in the memory. They enable a program to access and process the objects. They are created by assignment statements. Okay, now let's have some interesting examples of variables and objects so that you can understand even better on how Python handles them. First example. Create 3 variables, all assigned with an integer value of 100. Do they correspond to 3 different integer objects or just one single object? Let's figure it out. Check the ID of the objects that these variables are pointing at. This little number sign indicates to Python that this line is a comment. It is not code to be run. Okay, then pause the program by adding an input statement. The input statement will suspend the program from running until you press a keystroke. A pause of the program can facilitate us to observe the outcome. The second task in the program is to check if we modify one of the variables, will others be altered? Let's modify value of variable c by adding 1 to it. Then we print out the value of a, b and c again, as well as the IDs of the objects that they will be pointing at after modifying c. Okay, now execute the program. We got the output of these print statements, followed by the pause message. From the output we can see a, b and c are sharing one single object ID. What does that mean? That means there is only one single object for the integer 100 and variable a, b and c are all pointing to that object. This shows the object uniqueness in Python. Okay, then comes to the second task of the program. Add 1 to variable c. A, b and c are pointing to the same object. Will modification of c alter the values of a and b? Let's figure it out. Press a key to resume the program. Got the result. C has been changed to 101. But A and B remained unchanged. IDs of both A and B shows that A and B are still pointing to the integer 100 object. However, C is now pointing to a new object. The attempt of modifying variable C created the new integer object 101. This is actually an example of object immutability. We will have a specific video class on object immutability later in this series of videos. For now, we learn from this example that if required, Python can change dynamically the object to which a variable is pointing to. Okay, another example. Consider this simple program. The program first assigns an integer value of 100 to variable a. Is it possible to assign value of other data type to variable a thereafter? For example, here the program tries to assign the string hello to variable a. In many programming languages, if you declare a variable of a particular data type, you cannot assign value of other data types to it. Let's see how Python differs from other languages. Run the program. Before the program was paused, variable a was assigned integer value of 100. Okay, press a key to resume the program. This is the result. This assignment statement successfully assigned the string hello to variable a. Now variable a has its data type changed from integer to string. In some other programming languages such as C and Java, variables are created by making use of declaration statements. The declaration statement specifies the data type of a variable. If a variable is declared to be an integer, assigning a string value to it will result in error. By contrast, in the case of Python, variables are adaptive to the data type of the objects assigned to them. Like the case we went through just then, we first assigned an integer to variable a. Then we assigned a string to it instead. Indeed, we can assign objects of whatever data type to a Python variable. We don't even need a declaration statement to create a variable in Python. The assignment statement itself alone will create the variable if the variable does not exist initially. In this example, upon this assignment was executed, Python created variable a and the integer object 100. Variable a was a name pointing to that object. Then when this assignment statement was executed, the string object, hello, was created. At the same time, Python made variable a to point to that new object. You can assign value, or more accurately speaking, object of any other data types to variable a. You can have other variables also pointing to the same object by assign the same value to them. That's how Python handles variables and objects. That's all for this video. Hope you find it useful. Thanks for watching. See you in the next video.